Hello and welcome to the Z-Hut. Today I would like to show you how you can use an Arduino board with a PIR sensor to make a motion detected camera trigger. Now for this tutorial I just hooked it up to my flash because with the camera here you wouldn't really be able to see anything, but with the flash when I trigger it you'll see the flash go off. Now both my camera and the flash use the same plugs, and most likely yours will too. So let's just demonstrate it. There you go. It detects the motion. Now I have this set up in the sketch so that you can put a delay between how long it'll actually wait before it'll take another picture. Now the PIR sensor has some adjustments on there. Just set both of those potentiometers on there to the absolute minimum. All that's going to be controlled in the Arduino board. Now besides the Arduino board, all we really got is a resistor here and a optical coupler. An optocoupler they're also known as. And what this does is it allows you to connect to your flash or camera. Most likely you're going to use this with a camera. But it allows you to connect to that device without an actual physical connection to the Arduino. It uses basically, there's an infrared diode and infrared transistor, and when the infrared diode lights up, it allows current to flow through the infrared transistor, and it's all enclosed in this little tiny chip here. And then I just got a little 330 ohm resistor on there because it won't handle the full 5 volts off the Arduino. It's rated for somewhere around 3 volts if I remember right. Now you can use almost any optocoupler with this project. Just make sure you use the proper resistance in it so you're not frying it. And the cameras and the flashes, they don't put much voltage through there. It's like between 1 and 3 volts, I think, 5 at the tops. So just check your instruction manual for your camera and hopefully it should say in there. Otherwise, if you use the one that I got listed on my website, and to find that parts list, just look in the description below. You'll find a link to the website. And I'm just using a Sharp. I forget the model number on it. But I will have that on the website. Then these PIR sensors, I'll have a link to where you can get one of these as well. I'm going to turn the power off so it doesn't keep going off. And they're real easy to hook up. And then, like I said, there's 2 potentiometers on here. Set them both to their minimum. And everything is being controlled, the timing, everything in the delays is being controlled by the Arduino microcontroller itself. And the only other thing we have is we've got our cable that comes off, and I just got my little plug here hooked up, and I made an adapter cable to hook it to the board. Now of course I'm going to be putting this in a project box, but for the demonstration I didn't want to put it in there because then of course you couldn't see how the circuit was laid out. And as for the circuit, I will have that schematic of that on the website as well, and it's pretty easy. I also have a copy of the Arduino Sketch on there as well, and there's not really a whole lot to it. This is a very good beginner's project. If you've never played with microcontrollers before and you're interested in building one of these, it is real simple, and you most likely would not have a problem building this. So I think what we'll do is we'll go over to the computer and we'll take a look at the Arduino Sketch real quick because I can't think of anything else to go over on the circuit here. Yeah, we'll do that then. So I'll catch you over at the computer in just a moment. Okay, I've got the Arduino IDE opened up here and got the sketch loaded in. Now as you can see, like I said, there's not much to this. This is an actual real simple program. So let's just get right into it. So first we're defining the pin that the PIR sensor's on. I used pin 8 on the Arduino. If you choose to use a different pin, you can do that. Just make sure you change this number. And then I'm defining the trigger pin for the camera, and this will be pin 2, and that goes out to the optical coupler to trigger that to then trigger your camera. And then I've got the int val, and that's just keeping track of if the PIR sensor is high or low, if it's been triggered or if it's not. So then we get down here to the void setup, and we're setting our pin modes. So the camera, of course, is the output, and the PIR is an input. Then we get down to the loop, and what we're doing here is val equals digital read to PIR. So what it's doing is it's digital reading the pin 8 on the Arduino, or whichever pin you decided to use, and then it checks if the value equals high. Then it goes through, digital writes the camera high, delays for 50 milliseconds, then digital writes the camera low. So it quick triggers the flash. You just need a real quick trigger to trigger it. And I found 50 works pretty good. Much less than that, it doesn't always trigger. And if you get too big of a number, it'll trigger the flash multiple times, or the camera multiple times, depending on your settings. And then right here, this is the delay, and I've got it set at 10,000 microseconds. So that's basically 10 seconds. And that's how long it will wait before it'll be able to go back into the loop and take another picture if it detects motion. Now, I would probably suggest switching this up to like a minute if you were going to be setting this up like as a trail cam. Otherwise, 10 seconds, it's going to take a lot of pictures if movement's being detected, so your SD card might fill up pretty quick. Then after that, I just got a delay in the actual sketch, so if it comes through and val isn't high, it just delays 50 milliseconds before it goes through and checks again, and that's just for stability. That's all that's for. And I found, again, 50 works fine for that. The only other thing I could think of to talk about with this little project is if your camera actually doesn't have an input plug, there is a way around that. What you would do, now this would be a little more complicated. I'm not sure, I might do a video on it, because it might be helpful to some of you. But you could use a servo motor to actually and set up, make a little bracket that goes on your camera. So if you just wanted to use a little cheap point and shoot camera, it would use the servo to push down the button to take your picture. And that it wouldn't be a whole lot more to be added. And if I think of it, I'll knock the sketch up for that. I don't know, I might do a video on it, I might not. But I'll try to remember to knock up that sketch, and I'll put it on the project's website as well. But if your camera does have a plug, this right here is going to work for you. And just remember, to change this number to however much of a delay you want between pictures. If you put 60,000 in there, that would be a minute delay, and you could go higher. I forget, there actually is a maximum number you can put in on a delay, but I've never gotten that high, so I quite honestly can't remember offhand, but I know it can be a pretty big number. So if you want to find that out, just look under the help section. There's some pages that goes through and tells you pretty much all the commands and what they do and how to use them and how to format everything. So, all right, with that, I can't really think of anything else to go over. Just a reminder, the sketch for the Arduino, the schematic, all that can be found on the website, and of course you'll find the link to that in the description below. And you click on that, and it'll bring you right to this project's web page. If you found this information useful, please give me a thumbs up and consider subscribing. I'm trying to do a video at minimum every other day, and the more time I get, the more videos I'll do. So with that, thank you for joining us here at the Z Hut today. I hope you have a great day, and remember, have fun building.